Welcome to lecture 9, summary of 8051 embedded C data types. These are the 8051 data types. Already I covered all the data types in the previous lectures. The today lecture I am going to be just give summarize of 8051 data types. To talk about data types, there are two important things you have to be considered. One is what is the type of data you are using for your application, and what is the bit size to represent that particular data. So these two things very important. The first data type unsigned char, the data range from 0 to 255. So 8-bit size is sufficient to represent this value. Signed char minus 128 to plus 127. For this also 8-bit size is sufficient to represent this data value. Unsigned int, it is 0 to 65,535. If you want to represent this data range, you require 16-bit data size. Signed in minus 32,768 to plus 32,761. To represent this data range, you require 16-bit data size. Other than that, there are three data types which is more related to 8051 microcontroller and its series of 8051. Here the first data type is related to the character data type. It occupies only a single byte of memory to represent that data. There are two types of the character data type. One is the unsigned char, another one is signed char. Unsigned char, the data range is 0 to 255. If you want to represent any value in between these, a single byte of memory is more than sufficient to represent this the data range. Unsigned char minus 128 to plus 127, that is the range. For that also you require single byte of memory is required to represent the data in between this range. This is 8-bit to represent unsigned character. This is signed character. This 8-bit is what is that? It is the magnitude of that particular value, and the MSB bit is to represent is a sign bit. Whether it is positive, it will represent it as 1. If it is 0, it is represented as positive. Here the ring representation, just for understanding, I will draw this diagram. Unsigned char, the data range is 0 to 255. It is a single byte memory location, so it is more sufficient to represent 0 to 255 with single byte memory. For example, you are passing the value in the unsigned character 256, 257 or 500, 512, 513, 545, whatever the value will send, the compiler won't give any error. Suppose you are passing 256, okay, what is the 256? You convert it into the hexadecimal, you will get 100. Okay, the MSB bit is what is that? 1, that is what is the truncate. The rest 2 value, that is 00. 00 means it is nothing but 00. That 00 is stored in the some location. The next 257, it is a 101. MSB bit is truncate, this is 01. To represent 257, it is what it is? 01. 258, 02. 259, 03. So on. So it won't get any error, but you have to be careful. We have to be use this unsigned character. You must use in between 0 to 255. More than also, it is going to be, your compiler is going to be what is that? Accept, but it will truncate the MSB bit, and the rest of the values it will consider that value is stored in that particular memory. And ring representation, just for understanding, here I used signed character, the data range minus 128 to plus 127. To represent this data range, single byte memory is more than sufficient. For example, minus 128, what is the data size? It is 8-bit. The value is what is that? 80. So on, minus 127, minus 100, and up to plus 127. Plus 127, it is 7F. All the sign number representation, there are three ways you can represent. One is 1's complement, another one is sign magnitude form, another one is 2's complement form. The 2's complement is what is that? The more the convenient as well as is a faster one. That's why, as well as it will consume very less space, because if you perform this 2's complement in the computer hardware, the computer hardware requirement is very less compared to the other two format. That's why many computer hardwares will accept the negative numbers in the 2's complement form. Okay, come to here, 127 only it is going to be accept minus 127, minus 128 to plus 127. Suppose you are passing plus 128. This is not in between this range, but you are passing plus 128 with the help of sign character. So the compiler won't give any error. The plus 128, what is the decimal value, sorry, hexadecimal value, it is what is that 80. 80 already what it is assigned to minus 128. Again, if you are passing plus to 128, what is that? It is going to be override. So you, as a programmer, you will get confused. You are getting 80, that value is related to minus 128 or plus 128. So you must take care of these things while you design any application. For example, you having, this is a vessel, okay, having a 5 liter is a capacity. You can pour water or milk or oil, some grains, whatever you can pour over here. It can be able to, what is that, take. Okay, if you don't tell, if you pour water means I won't going to be accepted. Don't. If it is a 5 liter, it is a can. You can pour anything, water or oil or milk or some grains. It's going to be accepted. Likewise only. Suppose it is a unsigned character. If suppose if you want to pass capital A, okay, without any single code, A. What is a A? It is converted into the hexadecimal. That value is what is that, stored in that single byte memory. For example 1, for example 8, for example 255. Yeah, it is going to be accepted. Okay, the compiler won't give any error. For example small a, for example small c, with a single code you will pass means what is that, ASCII value of this c has to be what is that, sent to what is that single byte memory. Okay, it will accept all the values. If you give minus 89 also, it is going to be accepted. Okay, it won't give any error, but as a designer you have to be careful. Suppose you are using the negative values, then there is a problem. Okay, if you are cross more than plus 127, suppose you are giving 128, 129, 130, so it is replicate of what is that, the negative numbers what we represented in the previous example we seen over here. Okay, 128 means 80, 128, 129 means 81, 82, 83, so on it will go. Suppose you are giving the negative numbers minus 128, it what will give 7f. Already 7f is assigned with plus 127. So these things and all you have to be considered. Okay, but as a compiler, if it is what is a single byte memory, it can able to accept all the values. But you have to be choose the appropriate data type. What is that? You will not get any errors as well as any flaws. So you have to be choose according to that. And one more very important thing, the many of the designers students, what is the mistake they are doing. For example, you are the data range is 145. You convert it into the hexadecimal, you will get 91. Suppose you want to represent this 91, you convert it into the what is that, binary. Why in the binary format only we are going to be stored in that particular memory. To represent this 145, the 8-bit memory is more than sufficient. No need to go for what is that, unsigned int and or unsigned char or unsigned int or signed int. With the help of unsigned char is more than sufficient to represent this 8-bit. Unsigned char also it is going to be support numbers. And 544, it is the 220, it is hexadecimal. You convert it to the binary, you will get 12 bit. Okay, with the help of unsigned char, not possible. Why? It is a single byte memory. Okay, it can able to accommodate only 8 bit. Now it is a 12 bit. Definitely you go for 16 bit data type only. 16 bit data type is what? It is a unsigned int. Next 4589. 11 ED is a hexadecimal for this decimal number. You convert it into the binary, you will get 16 bit. 16 bit, definitely you are in need of unsigned int. With the help of unsigned char or signed char, you can't able to what is that accommodate these values. Okay, so these are the things. What is the type of data and what is the size of data? According to that, you can choose your data type. For example, it is a negative number minus 89. I want to what is that store the concerned value in that memory. 89 is a binary number. Again, you take a ones complement and two's complement. You getting 87. So 87 you can represent with the help of 8 bit. Even though it is a negative number, with the help of signed character can able to accommodate, because in signed character what is the data range minus 128 to plus 127, so you will not get any issues. Okay, so signed character we can use. I will give the more clarity with some example. Just you can listen this example very carefully. I am going to be pass all the values. Here I taken sign char. Okay, in the single quote I am passing 1 means the ASCII value of 1 is going to be displayed. 1, it is the decimal number, that is what is that, sorry, it is an hexadecimal number. 1 is a decimal number, but in that memory it is going to be stored as a hexadecimal number. 2, it has to be, it is a decimal number, while it is transferring to the P1, the according to that hexadecimal number only going to be displayed. Minus 2, it is a negative number. In the single quote capital A means ASCII value, in the single quote small a means ASCII value. Minus 89, yeah, fine. So signed character it going to be support. So you see minus 128, okay, it will going to be support, but you are giving minus 129, it won't support. But the sign, the data range is minus 128 to plus 127, but even though you are giving as well as plus 128 also won't support, because it is a signed character type. As well as you are passing 256, 257 and 511 and 512 and 513. So if you want to represent these things and all, you definitely require 16-bit data size memory is required, 2-byte memory is required. But even though this compiler won't give any error, it will, as I already told, 256 it is what is it, 100. The 1 it is going to be eliminated, the remaining the rest to 00, you represented in the exact the binary 00000000. That is going to be passed to the P1. It won't give any error, but as a designer you have to be careful. So which data type? Sign. Okay, it is minus 128 to plus 127 only possible. More than it will give, there is what is that, some misconception in your application. Now I am going to be save over here. I explain with the help of Kale tool. You can able to understand very clearly. The same program, unsigned int z I am passing the integer number. Here you can use character also, no issue. The character can the data range from 0 to 255. Here we are using 0 to 15 only. The z, it is an identifier. The data type is unsigned int. If you are using char also, will not give any error. As I told in this, here in the vessel, it is a 5-liter vessel, can accept number, ASCII value of character or a number, and negative value also. Whatever the value you are applying, it will going to be what is that, accept. Okay, it won't give any error. But as a designer you have to be taking care. Okay, now I am going for simulation. Just you can carefully have to be listen. This is very important part of data type. I am summarizing this one. Okay, the first I am going to be transfer the single code 1. What it is, the ASCII value of 1 is 31. The next I am passing 1 in hexadecimal. It is what is that, 01. In the binary format 400001. The next value 2. Fine, 1 0. The next value it is what is that? Minus 2. Minus 2 means what it is? Fe. Already in the previous class we discussed for minus 2. Okay, you represent it in the positive number and take a 1's complement, and you can add 1, so that is a 2's complement, you will get Fe. That Fe is displayed over there. The next, small a within the code, so ASCII value of that a is how much? It is 41. The next, it is a minus 89, so sorry, the small a it is 61, the capital A it is 41. The next, A7, minus 89 is A7. Already I given the demonstration. I will take 89 as a value. You take a 2's complement, you will get A7. Okay, the next I am passing minus 128, so it is 80. So 80 you are getting over here. Minus 128, 100, 0000, it is what is that? 80. Is the most significant bit, it represented as a sign digit. 1 means it represents negative, so it is a negative. So whatever the negative number, you see the MSB bit, all the bits are 1. If it is the positive number 0 to plus 127, all the numbers are what is that? 0. Why? Because it is a positive. The next 80 for 128, it's over. The next 7f. You see here there is a flaw. Here minus 129, that is not in the sign character range, but it is showing 7f. Already 7f is allotted to where? Plus 127, 0, 111, 1111. So there is a flaw. Okay, you have to be take care these things and all. Okay, you blindly you don't choose the data type. Correctly you can choose the data type, then only your application has to be run in proper way. Now plus 128, plus 128 also it will show. Here again there is a flaw. 80, it is for 120 minus 128, but plus 128 it is showing 80. So again it is a flaw. The next 81 for 129 and 256. Already told 256 you convert it into the hexadecimal, you will get 100. So MSB bit it is going to be truncated, the rest is 00. So 00 you represent it in the binary format 4040. Again flaw. 257. It is what is that? 101. The MSB is truncated, the rest 01 is going to be represented. The next what it is? 511. 511 is what is that? It is what is that? The ring representation. Okay, the first the ring completed. Next ring, it is a 511. 255 is represented as 55. 511 means what is that? The 255 value is what is that? FF. So that value is what is that? Passed to 255. So that is FF. The next 511, sorry, 511 is FF. 512 is what is that? 0. Yeah, FF. The next it will start from again 0. The next it is 513. It is a 0 1. So MSB it is going to be truncated. The rest values it is going to be represented. So sign number, the value, the range is minus 128 to plus 128. Suppose if you want to display or else store in the single byte memory, everything what is that you can take. Okay, it won't give any error, it will going to be represent, but as a designer you have to be taking care. Suppose you are in case of signed character, if sign char, you are using the unsigned char, if you are not using any negative values, 0 to 256 only can able to what is that? Represent in the single byte memory. If you go beyond the 256, 257, 511, 512, 1000 or it is won't possible. Okay, those things and all you need to consider. According to that you can choose the data type. So that is the very much important of data type. For representing 8 bit, you no need of what is that? Unsigned int. Okay, this is a 16 bit. Once you can use this unsigned int over here in the memory location, it occupies 2 bytes. Okay, but if you are using only the 8 bit to represent, in that 2 byte, 1 byte is what is that waste. Okay, it occupies more the program memory. Okay, that control had to be taken. The last three data types already the signed int and unsigned int is this more related to the unsigned char and signed char. Okay, that is the data range 0 to 65,535. So if it is a more than 8 bit you want to represent, definitely go for unsigned int, or else unsigned char is more than sufficient to represent 8 bit data. The next last three data types, the more related to the 8051, it is a bit in the RAM location 00 to FF in the bit addressable memory. If you want to access the single bit, if possible with the help of bit data type. And S-bit data type in SFR, if you want to access a single bit, very few register having the bit addressable, the rest are not bit addressable. So if you want to access the single bit in SFR in the any of the register with the help of S-bit, it possible. The last data type is SFR. If you want to access the entire byte, for example PTL is a single byte, it is 8 bit. If you want to access the entire byte with the help of SFR, it possible. It possible with not only the bit addressable, anywhere from the location 80H to FF with the help of SFR we can what is that access. If you are, suppose you want to access TH1, yeah, possible. SFR TH1 is equal to 0x8t UK1. So it is a correct syntax. It is going to be what is that access this particular memory location. Okay, it is related to TH1. That's all about the 8051 data types. So what is the type of data and what is the size of that particular data to represent it in the memory? You have to be careful. You can choose the data type. Thank you.